Hi, and welcome to the URI Watershed Watch Dissolved Oxygen Test Kit video. So your test kit will come in a variety of different boxes, but essentially the important ingredients will be an array of reagents in squeeze bottles. There will be sampling bottles, graduated cylinder, direct read titrator. There will also be information on the chemicals in here along with step-by-step instructions. These are also in our monitoring manual. Some important things to know about this test kit is these are bona fide chemicals, including some acid. So we do provide you with one pair of gloves. We also provide you with eyewear. If you wear glasses like I do, you don't have to worry about it. That should be enough to protect you. You're going to collect your samples either directly into the sample bottle if you're monitoring a stream, just by putting it down into the water, turning it up until it's completely full, and then capping it, or using one of our samplers. The important thing to know about dissolved oxygen bottles is they have to be completely full. See, no bubbles. That is what you're going for, no bubbles. But that's also why we recommend the use of a paper plate on the surface that you're going to be doing your dissolved oxygen processing on, because you're going to be adding chemicals to an already full bottle, which means there will be overflow. We also recommend having some paper towels nearby to protect yourself from that overflow chemicals. So the first step is to add 8 drops of our manganese sulfate reagent, also known as number 1. You want to make sure your bottle is capped in between use, because we don't want to introduce any oxygen from the atmosphere. So we're going to add 8 drops, holding the bottle nice and vertical so that we get nice even drops. And if you lose track of 1 drop, not a big deal. Then we're going to add 8 drops of our alkaline potassium azide, or as we prefer to call it, number 2. And the nice thing with these bottles is that you have to get a little squeeze in order for the drops to come out. So you can see we've added our second reagent, and we've started to see a reaction. I'm going to take my paper towel, wrap that around, and then I want to shake it really good. We want to use what we call an inverted wrist shake, where we're basically turning the bottle upside down completely. And we want to shake this very vigorously for about 30 to 60 seconds, because what's happening now is the chemicals in that water are reacting with the dissolved oxygen and creating a precipitate. That's what that cloudiness is. So we're going to shake it really, really well. And you can see we've got a lot of nice precipitate in there, and it's kind of cloudy. And so what we want to do now is wait until that precipitate is settled. We'll shake it again just to make sure we've had complete reaction, and then we'll go on to our next step. So after the precipitate settles down, and you really only need it to settle down to about the neck of the bottle, you'll see that it's settled. So now we can go on to the next step, which is adding 8 drops of our acid, also uric acid. That's the one with the red cap. This is acid. You do not want to get it into cuts or skin or into your eyes. So we're going to add 8 drops. And you'll see that the sample will start to swirl around and hopefully start becoming a little clearer. So we're going to, again, put the cap on. We had some more overflow. It's really important that we put paper towel around. And we're going to shake this really vigorously, again, for about 30 seconds. And what we should get is a nice clear yellow solution. At this point, our sample is what we call fixed. We don't have to worry about any oxygen getting into the sample and making it inaccurate from the air, because now all the titration we're going to do is based on the reaction that's already happened. So the next step is to fill our titrator vial. That's this glass bottle with a plastic cap. And the vials come marked, but we want to be super precise, so our kits also include a graduated cylinder. We found that some of these bottles were not as precise as we would like them. So we're gonna add 20 mils to that black line. And when you measure into the graduated cylinder, you want the bottom of the meniscus, that curved portion, to be right at the line. It looks pretty good. I'm gonna pour this in here. And then I'm going to put my cap in place. And I like to keep the bottles capped when I'm not working with them, not because I'm worried about the air at this point, but I don't want to knock it over. So next step is to fill our titrating syringe, or titrator. That's this green and pink syringe. So we're going to fit it into our sodium thiosulfate titrant bottle. It's got a little hole in the top that this tip fits in nicely. So now we're going to carefully, with the tip in there securely, turn the titrator upside down, the titrant bottle on top, and then just move it in and out a few times to get the titrator nice and wetted up. And then you want to carefully, once there are no air bubbles in there, you're going to draw it back about as far as you can go without pulling it out. And then you want to push the ring up right to the 0 line. So this is a direct read titrator, so it's really important that we have that set right at 0. So now we can put this titrator tip into our titrator vial. It holds it nicely. And we're going to add 1 drop at a time to a pale yellow. And this is really subjective. It is totally up to you what you consider pale yellow. This is a relatively pale sample to begin with. We want to be careful not to go to clear. So we want to just add 1 drop and swirl to mix it carefully and well. And I don't want to go to clear, so you can see that this is less yellow than our fixed sample, so this is pretty good. I'm going to carefully remove my titrator vial cap with the titrator in place because I don't want to move that plunger at all. Then I'm going to add 8 drops of my start indicator. And you'll see that my solution is now turning blue. If this sample had started out much darker and I hadn't titrated to as pale a yellow, this solution might be really dark, almost blue-black. Or this year we've been seeing that some of our starch indicator is actually making the solution look more pink or purple. It's working fine, it's just not quite as vivid a color. So this is now ready for our final titration. So we want to be very carefully adding 1 drop at a time, swirling in between until this final solution is clear. I'm going to add a drop, swirl it around to mix it. And you want to make sure that this is well mixed, particularly as you get close to that end point, that clear. Okay, so you can see that's clear. One of the other nice things about having a white paper towel or a white plate is you can look at it and make sure it's actually really clear. Sometimes it may look clear when you're looking at it, particularly if you've got a blue background or a blue jacket on. And then when you hold it up to white, you realize you just need to add a little tiny bit more thiosulfate to get that final reading. And the way we get our dissolved oxygen reading is we actually read it right off of our titrator. So counting from the top down, 0 down. This was tap water, which tends to be very low in oxygen, so This is 1, each of these little lines is 0.2, so this is 1.4 is how I would read this. And that would be the number that I would report on my postcard for my first dissolved oxygen. You can see this bottle's got plenty more of this fixed solution in it. We ask that you actually discard this and run the test again using another 20 mils. And if, when you do that second test, you find that your two values are more than a whole unit apart, we ask that you run the test a third time. And you will see that there is plenty of solution in here to run a third test. And this repetition is important for ensuring that the value that you are reporting is in fact the correct value. As with everything, the instructions are in our monitoring manual, which is accessible online, and we are very happy to answer questions. When you're done doing your sample analysis, you titrate everything, just rinse everything with tap water, let dry, and put away until the next time you need to do your dissolved oxygen monitoring. Thanks.